So page 227, chatty people. Number 28. It looks really horrible because it's got a lot of words.
Oh, yeah.
Yeah. But it's the last one with 3 variables, so we might as well use it. The owner, I don't care about the, oh, well, actually, we do need that one. The owner of Danvers Ford found that he sold a total of 520 cars. 520 cars. Okay. Really? Escape and Explorers last year. He paid the sales staff a commission for $100 for every car, $200 for every Escape, $300 for every Explorer. The total of these commissions last year was $87,000. Let me write that down, just for fun. Okay. In the coming year, he's contemplating an increase so that the commissions will be $100 for every car, $250 for every Escape, with no change in the commission for the Explorer. If sales are the same this year as they were last year, the compensation will be $106,500. How many vehicles in each category were sold last year? Okay. So, what do we need? What kind of categories do we have?
Escapes.
Explorers, Escapes. Any others?
Well, car.
Car. You know, Fusion, Fiesta, whatever else they have. All right, what else how are we separating these ideas?
By the amount of commission.
All right, so the commission for a car is
100.
100. The commission for the next car is
Escape is 200.
200. The next
Explorer is 300.
300. And then they're going to increase it the next year
To 150, 250.
150, 250,
Escape is no change.
and the Escape is no change, so that'll be 300.
No.
Oh, wait a minute.
Hey, but that's not right.
Did you say Escape with no change?
Yeah.
No. You're right. Explorer straight.
No. It's,
Yeah, that's right.
It's 200 first. It said Escape with no change.
The total
That'll
of
be
the
200.
Oh,
Instead of
yeah.
250.
and 300 in the coming year, so it'll be
250 for every Escape with no change to the commission for Explorer.
with no change in commission and Explorer sales. Yeah. So this one stays the same. All right. What's the other thing that we know? I mean, that'll give us 2 equations. It doesn't give us a third one. So what else do we know?
We got total commissions 87,000.
For the first one, right? So that's going to come down here at the bottom of this one.
And if they were the same last year, they'd be 106.5.
106.5 will be the total for this one. All right, what else is missing? Something else is missing in this.
How many vehicles for each?
How many vehicles for each? So the question is, how many cars did you sell?
Don't know.
So you call it
X.
X. How many Escapes did you sell?
Y.
You don't know, so you call it Y. How many Explorers? Z. And how many total cars did you sell?
Don't know. Oh, 520.
520. So here's the question. The last one is actually the easiest equation. X plus Y plus Z is equal to 520. How do I create an equation out of 100, 200, 300, and 87,000? Well, if it's $100 for every car you sell, how do you figure out how much money went towards the cars? If you sold 5 cars, you'd get $500. If you sold 7 cars, you'd get $700. I sold X cars, so this would be 100X. And therefore, this is going to be 200 Y, 300 Z. This will be 150 X, 250 Y, 300 Z. So what are the 3 equations? Start with the easiest one on top. What's the easiest equation here? What is going to get added together?
100 and 150.
100 X plus 200 Y plus 300 Z. Why do I know that those 3 are getting added together? Because I have a total amount. So this amount plus this amount plus this amount must be $87,000. All right, what's the next equation? Ooh, 1 0. Hmm?
150.
150X, 250Y, plus 300z, $106,500. Yeah. All right, and the last equation. One more equation. X plus y plus z is equal to 520. So there's our system. It's not a pretty system, it's got large numbers. I guess one thing you can do to make the top two equations a little simpler is divide by, well, you can divide the top one by 100, divide the bottom one by 10, and leave the bottom one alone. So let's rewrite it in that order. So if I divide the top one by 100, we're going to get x plus 2y plus 3z is equal to 870. Divide the middle one by 10, we'll get 15x plus 25y plus 30z is equal to, what's that, 10,650? And then finally, x plus y plus z equals 520. Now that middle one also has a common factor of 5, and you can reduce it again if you want, but I'm sick of reducing. Because I don't want to copy it down again. So what can I get rid of nice and easily?
Top and bottom.
Which letter? That's the important thing. Are we going to get rid of all the x's, or are we going to get rid of all the y's or the z's?
X.
X looks pretty much the simplest one. So if we're going to get rid of x, let's call this equation A, let's call this equation B, let's call this one equation C. How do I get rid of x between A and B? Change this one to
15.
negative 15. So I'm going to take A and multiply it by negative 15 and leave B alone. Okay, distribute negative 15 through the A equation. You're going to get negative 15x, negative 30y, negative, what's that, 45? Z is equal to, I have no idea. So it's negative 15 times 870. Calculator.
13,050. Negative 13,050.
Negative 13,050. It's an ugly number. And then just copy B down. That's 15x plus 25y plus 30z is equal to 10,650. And add them together. What do we get?
Negative 5y.
Negative 5y.
Negative 15z.
Negative 15z. Let's see.
120. No. 4,400.
2,400. Negative 2,400.
Yeah.
Okay. So that's one of our equations. Now we have to continue the same manner. We have to get rid of the x's between B and C. So how do I get rid of the x's between B and C?
Multiply 1 by negative 1.
Okay.
The bottom one.
Just by negative 1? Or are you looking at A and C?
A and C.
That's what I was saying.
Okay. That'd be fine. A and C. So you would take the bottom one and multiply by negative 1?
Mm-hmm.
Okay, so leave A alone. Take C and multiply by negative. A is x plus 2y plus 3z equals 870. And negative C would be negative x, negative y, negative z is equal to negative 520. And add them together.
Y plus 2z is 320. 350, I mean.
350. And there's your other equation. I see something that might make life a little easier. What's common with this first equation up here?
Factor of 3. Factor
3.
of 5, I mean.
Factor out of 5. So if I divide it by 5 and write it here, you would get negative y, negative 3z is equal to, I have no idea,
480.
480.
Negative 40.
Negative 480. And if I copy this one down underneath it, it actually turns out to be nice. What happens automatically if I add them together? The y's go away. You're left with negative 1 z is equal to negative 130. Therefore, z is equal to 130. Z equals what, though? What is z? 130 what?
Cars?
Nope.
Explorers.
Explorers. Because x is cars, y is escapes, and z is explorers. So this is explorers. Okay. So how do I find the rest?
Plug Z in it.
Plug z into an equation that has a y in it. Oh, there's one right there. Let's plug it in over here. So backtrack time. We plug it in, we're going to get y plus 2 times 130 is equal to 350. Y plus 260 is equal to 350. Therefore, y is equal to, subtract it over, 90. And y represents what? Escapes. So, escapes. And then finally, where do we go from there? The easiest one over here is x plus y plus z equals 520. So we'll end up over here. We know x is equal to, well, no, we don't know what x is. We know y is equal to 90. We know z is equal to 130. And we sold 520 cars. So 90, 130, that's 220. 300? When I do math in my head, it's usually not a good idea. 300?
Yeah.
Okay. So x is 300, and this, of course, is what's left over is the cars. So they sold 300 cars, 90 escapes, and 130 explorers. All that just to find 3 lousy little answers.
Yeah, they should have just kept up with it at the beginning. They would be asking us to
I
figure
know, isn't that horrible? Life should just throw answers at us instead of us going and searching for them.
Make it easier.
Yeah, but then it would get boring.
Killing all these trees, figuring out this one problem.
It's all recyclable now. All right, let's do one more linear inequality.
Don't erase the last part.
I won't.
You did.
Oh, x plus y plus z equals.
No.
You just substituted it.
Oh, yeah.
Yeah, that's nothing. Inequality. Let's see what happens. Now, I'm going to let you have a choice on how you want to do these on the test. You can do it the way the book does it and shade it toward each other, or you can do it my suggestion, which is away from each other, and then the answer turns out to be the blank space, the white space, which I think is a lot easier. But either way, you're going to have to graph these lines correctly. So don't worry about the shading until you get the lines perfect. So if I'm going to graph these lines, what do I need to do first? Solve them both for y. So probably the best thing to do is to write them next to each other. So you can get a good feel for what's going on with both of them. Do not lose the inequalities. That becomes really important. You can't change a greater than into an equal. So some of you do that. You have to be very, very careful to keep that sign all the way through the problem. All right, so if I solve the first one for y, what's the first step?
Subtract 2x.
get the 3x to the other side, so you're going to get 3y less than negative 3x plus 5. And then divide everybody by
3.
Whoa,
Two.
I made a mistake. It should be a 2. Erase this. 2. All right, and then divide everybody by 3. The number in front of the y. So we'll get y is less than, that doesn't change, right? When does it change? When you divide by negative. This will be negative 2/3 times x plus 5/3. Ooh. Can I change a number? Just to make our life a little bit easier. Change a 5 into a 6. I wasn't thinking when I wrote it. And therefore, this is really just 2. That makes our life a little bit easier. Okay, so y is less than negative 2/3 x plus 2. All right, before we even bother graphing that, let's get the other one. First step here,
Sure, I got the 2. I mean, x.
subtract the x, so we're going to get negative 2y greater than or equal to negative x plus 8. Keep it in the y equals mx plus b order. So you can pull off the slope easily and pull off the y-intercept. Divide everybody by negative 2, and here you have to be cautious.
Change
That change from greater than or equal to
on.
less than or equal to. Negative divided by a negative is a positive. Write it as a half, though, so that you can see what the slope is instead of x over 2, which would have confused the heck out of most people. Positive 8 divided by negative 2?
Negative 4.
Negative 4. All right. What is the slope of the first line?
Negative 2/3 x. Negative 2/3.
Negative 2/3. So here m is equal to negative 2/3, or change in y over change in x. Don't forget that. Y-intercept as a coordinate? 0, 2. Over here the slope is 1/2. And the y-intercept? 0, negative 4. Okay. Are the lines parallel? Are the lines perpendicular?
Yep.
Why?
Problem.
Oh, just because I asked?
Yeah.
No. What makes them parallel? What makes them parallel? If their slopes are exactly the same, are they exactly the same?
No.
No. What makes them perpendicular?
They're the exact opposites.
If you multiply them together, it comes out to be negative 1, or they flip and change signs. If you flip negative 2/3, you get 3/2. Is that the same thing as 1/2?
No.
No. So they're neither parallel nor perpendicular, but they do intersect. Just little review questions. So let's graph them. Not too bad. All right, let's see. I will graph this one in green and this one in blue. Be so much easier to just say f of x and g of x, but we'll do that in the next chapter. All right, so if I'm going to graph the first one, y is less than negative 2/3 x plus 2, where do I go? Up to, plot a point. And the slope is
Negative 2/3.
down 2, which brings you to the origin, and to the right 3. Now make sure if you draw a line between these 2 points, what kind of slope is that going to have?
Negative.
Negative. Make sure it corresponds to what it says over there. It's a negative slope. So we can do it again. 1, 2, and then right 3. What kind of line is it going to be?
Straight
Dotted. All lines are straight. Hey. It's going to be a dotted line, so I'm going to do another slope point right here, just to kind of keep my eye going straight. Yeah, that's pretty good. Of course, it goes on forever in both directions. I'll worry about shading in a second. I want to get the other line. So the other line starts
Down 4.
down 4, plot a point. The slope there is
Up 1 over 2.
up 1 over 2. And I'm going to do a couple of them. Up 1 over 2, up 1 over 2. What kind of line is this one going to have?
Positive.
Oh, what kind of slope is it going to have? Yeah, positive. Make sure it corresponds. And it's going to be a solid line. Yeah, I messed that one up a little bit. Okay. Now let's get the shading in. Do we want to do reverse shading or same side shading? The computer's going to go same side. So do you want me to practice that, or do you want me to do reverse shading so the white space becomes your answer? Now there's only 4 places for the answer to be. It could be in this little corner, could be up here, could be over here to the left, or straight down. That's the only options, because when you have 2 lines intersecting, it cuts the plane into 4 pieces. So if you want to do reverse shading, what will happen is the white space will become your answer. If you want to do normal shading, it'll be where the 2 lines come, or the shading comes together.
Which one are you not going to take off for?
I'm not going to take off for either of them, as long as you tell me. One way or the other, you have to say ANS and put an arrow to the region. Like if you want this to be your answer, I want ANS up here and a little arrow going to the region, telling me that's what your answer is. Answer, ANS. Answer. It's just an abbreviation. It's on a calculator too. So let's go same side shading, even though that's messy. Blue line. If we look at -4 as the y-intercept, it says go down because it says y is less than that y-intercept, so it's got a shade on that side. So I'm going to make a lot of little lines here so we can see where the overlap is going to happen. I'm going to shade on this side of the blue line. This is a lot better with chalk because you can sit there with chalk and literally shade it in. Pencils are sometimes good too, if you get them on their edge. Put a ton of blue lines in here. All right, so that is the shaded region for the blue line. It is less than 1/2 x minus 4. All right, the green line. This one is y is less than -2/3 x plus 2. So we go to the y-intercept. Which way do we point the arrow?
Down.
Down. So we're going to shade that side of the green one. Make sure that if you're using lines to change the angle of the line so they don't run parallel to each other. So I'm going to go this way. We get all this region is the solution for the green line. Where do the shaded regions intersect each other?
Down there.
Down here. So this region down here, I'll put it in black. This is going to be your answer. Below the blue line and to the left of the green line. So all of this region straight down, this is going to be our answer, this region here. So where it's just blue, that's not part of our answer. Where it's just green, that's not part of our answer. And where it's nothingness, that's not part of our answer either. So the only answer is below the green line and below the blue line in this region here. And that's all there is to inequality graphing.
That's it.
That's it. Now, if there's 3 lines that you have to graph, it gets a little trickier and it's best to go opposite shading. Because if you have 3 lines intersecting, it's really hard to tell where all the 3 shades are running into each other. The computer does a better job of it than you could ever do by hand. Yeah, pretty neat. Okay, so that's everything that's on the test. Solving systems of equations, 2, 3, don't forget substitution, and we're going to practice them on Tuesday and Thursday before the test on Friday. But today and Wednesday, I'm going to be teaching you something new so we don't get behind.
So we get confused.
Nah, something new has nothing to do with drawing lines. You just think you're going to be confused. So chapter 5, which is just polynomials. Pretty much for the rest of the course, we're going to talk about polynomials. And I start off polynomials totally different from the book, so just let me have my fun.
There's more graphing.
There will be, eventually, but it's not the same type of graphing.
That's what you
But
said
I don't
last
think
time.
it's in, I don't think there's any graphing in chapter 5. Or not much. nothing I can see that's impressive. So 5-1. Oh,
That's a long one. Introduction to polynomials and polynomial.
yeah, blah, blah, blah. 5-1. Poly intro. There, let's just abbreviate it and be done with it. Now, polynomials, you've been playing with them enough. You've seen them. They look like this. That's one type of polynomial. This is called a trinomial. We've been playing with these a lot, especially that last example. That's a polynomial. It's called a linear one because it has a slope and a y-intercept. So what makes a polynomial a polynomial? It's really hard to define a polynomial without talking about its pieces first. So these are the pieces of a polynomial. 2x, -3, +2, +3x, and x squared. So if I even added these together, it would give me another polynomial. So what I want to talk about is not a polynomial as a whole, but let's talk about what makes a poly term. Terms are separated by addition and subtraction. So that's why I circled the x squared, the 3x, the 2, the -3, and the +2x, because they're connected with addition and subtraction. So a polynomial term is the product of a real number, which has a fancy name, coefficient. I always forget if there's 2 f's in coefficient or 1 f in coefficient. Oh well. And a variable or variables. It could be like x, y, x times y. Raised to a whole number power. What's a whole number? What's a whole number? Nobody remembers what a whole number is? It starts with a 0. Next number is? 1. Next number is? 2, 3, 4, and all the way up. So when you're talking about a whole number, you're talking about the set of numbers that starts at 0 and then turns into the counting numbers. And it goes off to, of course, infinity. What are not whole numbers? Well, negative numbers are not whole numbers. Fractions and decimals are not whole numbers. And things like pi and square root of 3 are definitely not whole numbers. Those are irrational numbers. So when we talk about these exponents, they have to be out of this list. 0, 1, 2, 3, 4, 5, 6. And off to infinity. So let me give you an example of something. Is this a polynomial? Poly? And question mark. Is that a polynomial? Why? Has a negative exponent. Because this thing is raised to the -2, it is not a poly. The 3 is fine, that's a coefficient. The x is fine, that's your variable, but the power is not a whole number power. All right? This one is a little strange. Is 5 a poly? Yep. Yes. Now, does it fit the definition? Is it the product of a real number coefficient and a variable raised to a whole number power? Where's the variable?
5.
5 is not a variable. 5 is a real number coefficient. So where's the variable?
Oh.
The trick is, when you raise something to a 0 power, what do you get?
1.
1. So you can write this as 5 times x raised to the 0, because that's just 5 times 1, which is 5. So it fits a polynomial, and it definitely is yes. Okay. Let me ask a sillier question. Is 4 over x a poly? Is
Yes.
4 over an x a polynomial? Yes? Yes? Why?
Because of the fraction.
Yeah, it's part of the reason, but what's the main reason? If I took that x and I brought it to the position where it's supposed to be, it's not supposed to be a quotient, it's supposed to be a product. If I change it into a product, it would be 4 times x raised to what power? -1. And therefore, it breaks the rule, you can't have a power that is negative. So this is not a poly. So with variables in the bottom, can't have them. Variables raised to negative exponents, can't have them. You can't even have this, 5 square root of x. That makes no sense as a polynomial because square root is not a power that is whole. It actually is a rational number, a half. We'll get to that later. So it has to look like, something like this. Oh, ax squared plus bx plus c. That would be a trinomial, right? Or we could write it as ax cubed plus bx squared plus cx plus d. The problem with this is a 4-term polynomial. This has 4 terms. 4 terms. One problem is labeling these things. This is a 4-term polynomial. If I wrote another one down, it could be a 5-term polynomial. What if I wrote this, though? That's a binomial. But the problem with it is, it doesn't really show a lot of similarities to things that look like 2x minus 3. So there's a better way of describing them than saying it's a binomial or a trinomial or any of those. This one over here is called linear because it draws a straight line. The one up here, we've added all these together, this is called a quadratic. And anything that has a power of 2 shares a lot more properties with this than it does with linear, even though it might only have 1 term. This one over here, this is called a cubic. So how am I labeling these things? What's making me label that one a cubic even though it has 2 terms compared to the linear? What's the only difference between these two? The exponent. So the exponent actually is a much more descriptive name for polynomials. When we talk about the exponents, we're talking about the highest one, largest one. That's the same thing as calling its degree. So when you're talking about a cubic, it's a 3rd degree polynomial. When you're talking about a linear one, it's a 1st degree polynomial. And when you're talking about a quadratic, it's a 2nd degree polynomial. So what's the highest degree I can have in a polynomial? 4? So the highest power I can have is x to the 4th.
Infinity.
Infinity. Well, not infinity, because infinity means you just keep on going. But I can get as big as I want. I can pick any number and say that's the degree of my polynomial, which can get a little ridiculous at times. All right, so now we have this new system that, by the way, you've been working with all your life. You don't believe me?
I don't believe you.
You don't believe me. This number here is a polynomial. 2,307. How do you write it in an expanded form?
TW0, TH.
No. Expanded form. What does this 2 really represent?
2,000.
It's 2 by itself, but because it's in the 4th position, it's times 1,000, which is 2 times 10 to the 3rd power. Plus, the 3 becomes 3 times 10 to the 2nd power, plus 0 times 10, plus 7 times 10 to the 0 power, if you want to think of it that way, which would be 1. So this could be 2x cubed plus 3x squared plus 0x plus 7. And that would be a perfectly fine polynomial. We didn't have to use 10 as our base. We could have used any number in the world. Think of it this way. Why do we use 10 as our base?
How we count?
No.
Finger.
We have 10 fingers. You know some cultures actually count up to 20?
Yeah.
Because they don't have where choose, they count on their toes too. That's a South American tribe. They used to, which South American tribe? Oh, the Mayans. You know, we're supposed to end in 2012 because of the Mayan calendar. But, so if you had like 6 fingers, what would your base be? 6. And then all these 10s would turn into 6s, and we'd be counting a different way, which would be kind of neat if you think about it. So once we get up this new stuff, these numbers that we're talking about, we can add them or subtract them. I usually just show subtraction because addition is simplistic. For instance, 2x cubed plus 4x minus 7 minus 5x squared plus 7x plus 8. There's 2 trinomials here. What's the degree of the first one?
The third.
It's the third power, so this would be degree 3. What's the degree of the second one?
Second.
2. 2. All right, how do I add these together or subtract them? What should I do first?
Combine like terms.
Before you can combine like terms, though, something's in the way.
The exponents.
No, the exponents aren't in the way. Parentheses. Please excuse my dear Aunt Sally. So you got to get rid of parentheses. So how do I get rid of the first ones?
Just erase them.
What's that? This one? No. How do I get rid of the parentheses in this first expression? How do you get rid of parentheses, period? With what? 1. What property? Nope.
Inverse multiple.
Nope.
Distributive.
Distributive. You're going to... Distributive. 1 times 2x cubed.
2x cubed.
2x cubed. I know it's trivial, but a lot of people forget that this is the distributive property, not some weird other thing. 1 times 4x.
Wow.
4x.
4x. 1 times negative 7. Negative 7. What
was the point?
To go back to those silly properties, because people do the weirdest thing. They want to multiply out 2x cubed times 5x squared. They want to start foiling or some silly thing like that. This has nothing to do with it because the operation is subtraction. So you've got to get rid of the parentheses, and to get rid of parentheses means distributive property. I know I'm getting a little picky, but you have to remember this part. So what am I going to distribute here?
Negative. Mean 1.
Negative 1. So put that 1 in there. Negative 1 times 5x squared is negative 5x squared. Where do most people make their mistake? Here and here. The 7x and the 8. Because these two are really close together, so most people get that one right. But then they forget to distribute it all the way through. So negative 1 times 7x? Negative 7x. Negative 1 times positive 8? Negative 8. Now what do? Combine like terms. What property is that? Commutative is the first piece. Commutative will get them next to each other. So if you have 5x next to 4x, what property allows you to write 9x? Yes, I'm going back to those silly properties again.
Inverse. Identity.
No, that's not.
Say the one that you want to say. Distributive. What do they have in common? X. You kick it out.
You just need to do 1. Don't put 2 and 3 on.
I'm just saying, this is the main one. If you're combining like terms, it's the distributive property because you're pulling the x away and you get 5 plus 4, better known as 9x. So anytime you're combining like terms, you're using, well in this case, the first property is just to get them next to each other, which is commutative. And the second one is distributive property to combine like terms. Distributive is always combined like terms. So what's like terms up here?
The 4x and the 7x and the 7, negative 7, negative 8.
And that's the only things. So 2x cubed is going to go first. You try to write this in descending order. So you want the highest degree first. Second highest degree would be?
Negative 5x.
The negative 5x squared. Don't lose any powers. 4x minus 7x.
Negative 3x.
Negative 3x. Negative 7 minus 8.
15.
Negative 15. And we're commuting all of these things, but I'm just pointing to them, but it is commutative property. Can I do anything else? Anything? Is there any other like terms to combine? No, so leave it alone. I've seen people do the weirdest thing. I've seen people go 2 minus 5 minus 3 minus 15 and come up with some answer with some power, which doesn't make any sense. It's only because they don't pay attention to the properties. So that's adding and subtracting a polynomial. Distribute to get rid of the parentheses and then just combine like terms. Not a big deal. Multiplying. This is the one you want to concentrate on. But don't concentrate on it to the exclusion of taking a subtraction problem and turning it into a multiplication problem. That's a common mistake. You're going to see these parentheses and you're going to be like, oh, I want to multiply it. Your first thing should be, what operation am I dealing with? And then go from there. So let's start off with something easy. Negative 3x squared times positive 4x cubed. And yes, we're going to use the properties to pull this apart so we get it in our heads the right way, instead of just guessing. Trust me, I've seen this before. I've seen people go negative 3 times 4, negative 3 times x cubed, x squared times 4, x squared times x cubed. What property are they thinking of?
Multiplicative.
Distributive,
Oh.
because they're distributing it. What should you be thinking? Well, you should be thinking that I need to get the numbers next to each other, and I need to get the variables next to each other. What property is that?
I'm guessing.
Whenever you're changing orders thing, and you start pointing at two things that are totally separate from each other, you're commuting to get them close. So if I commute the numbers next to each other, you get negative 3 times 4. And if I commute the variables next to each other, you're going to get x squared times x cubed. This is what's really going on when you multiply those two terms together. It's commutative, and that's it. Negative 3 times 4? Negative 12. X squared times x cubed?
X to the fifth.
X to the fifth. Base times base, what do you do with the exponents? Add them. So this would be x to the fifth. I know I'm getting nitpicky about this, but I know what mistakes will happen. And they happen all the time because people are like, oh, I know this, and then they start doing weird stuff. Like x plus x equals x squared. That's the one that really gets me. X plus one apple plus another apple is apple squared. Or even worse, I've seen people go x times x is 2x.
We look at me for.
You did that. When we were doing exponentials, you did that. I remember too.
That's embarrassing. You can't just pull.
It's like, I'll be doing it to you soon enough.
She's right. That was embarrassing.
Sad. Another example. Negative 2x cubed times 4x squared minus 5x. A monomial times a binomial. What property takes over here?
Distributive.
Distributive. We got to get rid of those parentheses. And while we're doing the distributive property, we're also going to be doing this commutative property here. Number to number, variable to variable, but that's only when they're multiplied together. So when we do negative 2x cubed, this whole thing, times 4x squared, it's number to number, which gives you negative 8, and letter to letter, which will give you x to the 5th power. Don't think of it as distributive, though. You're not distributing anything. You're just commuting to get number to number and variable to variable, just like this over here. That's all you're doing. All right, and then finally, negative 2x cubed times negative 5x. Highly suggest you take care of the negatives first. Negative times a negative?
Positive.
Put a plus down. 2 times 5 is 10. And x cubed times x. X to the 4th. I think a lot of people think that's distributive because as I move my finger, I'm going here to here, here to here. And they see that as the same motion as distributive property, but it's not. It's just combining the number to the number and the variable to variable. Is there anything else I can do with this? Nope. Done. You can't combine them. They're unlike terms. I don't want you thinking of factoring. We'll deal with that later. All right, how about this one? 4x squared plus 1 times 2x minus 3. Binomial times a binomial. What property? Distributive. I'm not going to say the word FOIL yet. So get that out of your head for just a second, because a lot of you are thinking FOIL is its own little property, and it's a great property except for one problem. It only works on a binomial times a binomial. I'd rather show you something that works all the time. So how does the distributive property work? This work is a little tricky. The distributive property says A times B plus C is equal to AB plus AC. So what is A up here? It's a single number times a binomial. Nope. 4x squared plus 1. This whole thing is A. It is the number sitting in front of another set of parentheses. So what you have to do is you have to consider 4x squared plus 1 as a single number. We'll shortcut it in a second, but I want to show you that it's actually the distributive property. So if this is A, what's B?
2x minus 3.
Nope,
Just 2x.
just 2x. What's C?
-3.
Well, the negative 3, and that would be C. It's a number sitting in front times two numbers that are added and or subtracted inside parentheses. Now, we could just as well have called 2x minus 3a and the other pieces b and c, but I chose this order. So we're going to take a and we're going to multiply it by the first one. So we're going to get 4x squared plus 1 times 2x. A times b. A times b. And then we're going to distribute it here, but I'm going to take care of something first. A positive times a negative is a negative, so I'm going to put the minus sign here. And then it's going to be 4x squared plus 1 times 3. Or negative 3. I guess we could have left the negative there. Let's leave the negative there. Let's make this plus, make this minus. I think it makes more sense to leave the negative with the 3. All right, now what? Well, now I have these two terms, and I have a monomial and a binomial for both of them. How do I take care of 2x times 4x squared plus 1?
8x cubed.
What property?
Distributive.
Distributive property. So we can distribute it, and we'll get 2x, I can go backwards. 2x times 4x squared is 8x cubed. 2x times positive 1,
2x.
it's a positive 2x. And then over here, I can distribute the negative 3. So negative 3 times 4x squared, negative 12x squared. And finally, negative 3 times 1 is negative 3. Okay, and then all we have to do is get it in order. 8x cubed goes first. Minus 12x squared comes second. Plus 2x comes third. And finally, minus 3. Now that's technically what's going on. What's the shortcut? Well, there's that FOIL. Let's see if it actually works. Where'd the 8x cubed come from? Well, that's 4x squared times 2x first.
That's FOIL.
Where'd the 12x come from? Well, that's 4x and negative 3. That's considered outer. You're going to the outer limits. Where'd the 2x come from? Well, that came from 1 times 2x, which is the inner. And then finally, the negative 3 is 1 times negative 3 is the last. So FOIL is just a shortcut language for the distributive property. But again, it only works on a binomial times a binomial. I've changed that up just a little bit, and FOIL all of a sudden falls apart.
What's FOIL?
First, outer, inner, last. If you have A plus B times C plus D, then your answer is going to be first, which is AC, outer, which is AD, inner, which is BC, and last, which is BD. First, outer, inner, last. FOIL. You don't remember that? Which is great, because I'd rather you say distributive, because look what's happening. It's A times C and A times D. That's the distributive property. And it's B times C and B times D, which is also distributive property. You're just distributing it over the second.